Okay, so main is just essentially calling all the other functions. Let's look at those other functions and how do they work? Well, notice display menu is pretty transparent, just prints out all these strings. Note that in the list function, we're using that fancy new enumerate function, which implicitly sets up a counter that's used to number the movies in the list. And that's what that does. The add function takes the string and uses the append method to the movie list and appends that name to it. Delete, the if statement in delete uses length to make sure that the index for the movie to be deleted is within valid limits, right? So this if statement, if you try to enter a number that is greater than the number of items that's in the movie list, you get this nasty message, invalid movie number. On the other hand, if you enter in a valid number, which is not the same as the index of that item is actually that number minus 1, right? Because we've numbered the movies 1, 2, 3, and 4. But in the list that contains those movies, the movie that's numbered 1 actually has an index of 0. So you have to do this little machination here and subtract 1 from the number. So you call the correct index number of that item and pop it off the list. Okay. And notice that because pop both removes it and returns the name, returns the name of the item, we can capture that here and print it out in this F statement right below. So you can always show the movie, print out the movie that was deleted. Okay. So that's pretty transparent. Notice though that the add and delete functions don't return the movie list after they change it. And we showed that in the slide. You can add something to a list or delete something from a list. And if the list is in memory, the function doesn't have to specifically return that list. So it manipulates what the contents of the movie list because it's still referred to in the main function. Okay, so that's about it. Notice again, the names of the functions are abbreviated from what we saw in the hierarchy chart. They're still meaningful. They're labels. They are labels that mean something to you and I, but fewer characters is better than more characters. So we try to give them some sort of terse name that nevertheless reflects what they do. Okay. So that's that. This is probably a good place to take a break. Okay, I've got 12:09, which is close enough to 12:10 for as far as I'm concerned. So let's come back at 12:25, okay? 15 minutes. I'll see you back here in 15 minutes. Thank you. Okay, so that's the basic information about lists. Now we can crank this up a little bit and start looking at two-dimensional lists, okay? Or you can have a list of lists. And it's pretty transparent how this works, right? So here we have a list of students, but within that list, there are three discrete lists, 3 different lists. Here's one, here's another one, here's another one, You can think of this, okay, if you think of a single, just a regular old list that is a sequence of items as I mentioned that it's an array. You can think of it as a one-dimensional array, where here you can think of it as 2 dimensions, right? Where each list is a row, and you can think of them as stacked on top of each other. So you have columns. For example, here you'd have first column would be the names of the students. The second one would be whatever these are, test scores, I suppose. So this is real easy to do. You just have to use the right syntax. Make sure you have brackets delineating each list as well as the beginning and end of the list of lists. And it wouldn't have to be 2-dimensional. If you say this is 2-dimensional, you could have a 3-dimensional list or a 4-dimensional list, which again is kind of hard to conceive of in terms of analog to a spreadsheet or a database, but you can. Okay, so how do we do this? Okay, well, let's see. Here we have a slide for this one. Which would be slide 28. So if we run this, it looks just like the slide. It doesn't return anything, but that's okay. We say, what are students? You can see students is a list of 3 lists. If we say, what are movies? Movies is similarly, it's a list of 3 lists. Now, let's try something, because I'm not sure what the answer to this is. Let's say that they're not all of the same size. I wonder if that would give us a problem. Do something like this. And evidently it doesn't. So each list does not have to be the same size or the same length, right? Which makes it more versatile, of course. Okay, so let's put it back the way it was. And let's go on to the next slide, and let's see, where are all those nasty slides? Right here. The same functions work. So if that is the same methods, I should be more precise about the words I use, the same methods that work on one-dimensional list or a one-dimensional array also work on a 2-dimensional array. Well, you can see how it works, but we also have a slide for that. So we're appending, right, this list to this list. So if we do this, let's just do it all at once. And we say, what is movies? You can see that separate list was appended to the original 2 list. Okay. So, that's pretty obvious. There's not much more I can say about this. So the movie list has three items for each movie. There's a name, there's the year it was released, and there is the cost. Okay. Now, so right now the movie list is just like it was in our original program, I believe. Now, how do you access items? Well, you might suspect you still use indexes, right? So it looks like this, but now you have to access any individual item, you have to use both the index of the list that you're accessing as well as the index of that item in the list. So for example, if we do something like this, if we say movies, and when you're indexing, of course, you use brackets, you don't use parentheses. If I just say, I want the first list in the list, we'll get the entire list, right? The entire first list. But if I say I just want, for example, the date of the release date for the Holy Grail, then I have to use two indexes. I have to say I want 0, which is that record, and then I have to say I want index 1, which is the date. And so that will pluck out the individual year that the Holy Grail was released. And if you just look at the structure of this thing, right, we've got 3 lists and there's 3 items in each list. You can access any one of the 9 items using 9 different combinations of 2 indexes, right? So that's how that works. Now, if you do something funky like this, if I say, I want movies, I want the 4th list in movies, and I want the name of the movie in the 4th list. So I do this, you get an error, and not just a general error, you get an index error. It tells you what's going on. List index is out of range because I tried to access the 4th list in that list of lists and there wasn't one. Or if I did something like this, I said movies, first movie, and I want the 4th item in the first movie. Same thing. Okay, the list index is out of range. Okay, so that's that. And again, you can call to the console the specific structure with just the name of the item, or if you want to make more work for yourself, you can say print the name of the list of lists like that. Now, print statements, however, can be your friends. If you just name the variable, for example, in a function, it's not going to print anything, right? So why this is a good reason why you might want to use the print statement to test things, particularly in functions, right? Functions generally return the last item or where it encounters a return statement, but it will always print out something. If you have a print statement anywhere in a function, when it encounters that command, it will print something out to the console. So printing can be a good way to figure out what you've done wrong when your program doesn't seem to do everything you want it to do. Okay. Now here we're going to take a look at some nested loops. Slide 32. Right, so what are we doing here? Well, this is kind of an amalgam of the 2 other slides. We create a 2-list here that we call movies. Notice the second one is not called movies, it's called movie. And then we append that independent single list called movie to movies right here. And then we walk what I call walking through the list, what the author calls processing the items in a list of lists. And we're using a nested loop to do it. Here's the outer loop. The outer loop will do what? Let's see what this does.